Okay, in this example, we have this initial value problem, y double prime plus 2y prime plus 2y equals 0, where the initial condition is y of 0 equals 1 and y prime of 0 is negative 1. So first off, notice that this is a second order linear homogeneous differential equation with constant coefficients. And so the way we're going to solve this is we're going to find the characteristic equation, which we can just read off the coefficients of the equation. So r squared plus 2 times r plus 2 is equal to 0. I just took off the coefficients here. And now we solve for r. And you're going to notice it's not factorable. And so I'm going to use the quadratic formula. And so I get r is negative 2, right, negative b plus or minus 2 squared minus 4 times 1 times 2, all divided by 2 times 1. And you're going to see the first term, negative 2 divided by 2 is negative 1, plus or minus, and then the square root here, you're going to notice that we get 4, right, 4 minus 8. And so in other words, we get negative 4 under the square root. And so that means we have a complex root, right? Square root of negative 4 is 2 times I. And then we're going to be dividing that by 2. And so in other words, we just get I. And so these are our two roots, negative 1 plus I and negative 1 minus I. And so in this case, our general solution is going to look like this. It's going to be y of x is e to the real part, so negative 1 times x, and then times a constant times the cosine of the coefficient on the imaginary part, which is also 1 times x, cosine x, or I'll just read it like that, cosine x, plus c2 times sine times the coefficient on the imaginary part, which again is just 1. So this is our general solution, and we still have to find the particular solution that corresponds with these initial conditions. Okay, so with the first condition, y of 0 is equal to 1. And if I plug in 0 into this function, well, this is going to become 1. The sine term is going to go to 0 because this is 0. And the cosine term is going to be 1 because cosine of 0 is 1. And so what I'm going to end up with on the left-hand side is 1 times c1. So that's just c1 is equal to 1. And so this actually gives us, right, it doesn't even have c2 involved because the cosine term gets canceled out. And so in other words, we can actually rewrite our general solution like this. Negative x times cosine of x plus c2 sine of x. But we still need to figure out c2, and the way we're going to do that is use the second condition with involving the derivative. And so we take the derivative of our general solution. This is what we're going to get. Y prime of x, we're taking the derivative of this equation. I could take the derivative of this equation, except then I would be using the c1, and I'll just end up with a little bit extra of algebra, moving the c1 around and stuff. So I'd rather just plug in my c1 value since I've already found it. And so here we have the product rule, right? We have an exponential times some sum of cosine and sine. And so product rule, first function times the derivative of the second, negative sine x, plus c2 cosine x, plus second function times the derivative of the first. Derivative of the first is minus e to the negative x times the second function. Okay, so now I could plug in y prime of, well, what's our initial condition? Y prime of 0 is negative 1 right away. I could plug that in right into this equation right here, but I'll do a little bit of simplifying to start. It's an optional step, whichever one is simpler. Maybe one is not simpler, they're just the same. But notice both terms have a e to the negative x in them. And then the first term I'm going to get a negative sine x plus c2 cosine x. And then this negative sign will distribute into this brackets. And so I get minus cosine x minus c2 sine x. And then you can see the two cosine terms can be combined and the two sine terms can be combined. And so I'll end up with e to the negative x, negative 1 minus c2 sine x plus c2 minus 1 cosine x. Again, optional, but I think it, when we plug it in, makes it a little bit simpler. So again, y prime of 0 is equal to negative 1. And so when I plug in 0 into this function, again, sine of x goes to 0, cosine of x becomes 1, and this also becomes 1. And so all these terms get canceled out except for the c2 minus 1. And so I get c2 minus 1 is equal to negative 1, and so c2 is equal to 0. Okay, so that means that actually the second term, right, if c2 is 0, then that means that this second term actually sort of isn't part of this actual solution. So now let's put it together, right? We found both of our constants. Let's put it together for the final answer. Y of x is c1, well, it's e to the negative x times 1 times cosine x plus 0 times sine x. So in other words, we can just simplify this and say it's e to the negative x times cosine x, and that is our final answer.